200 miles west of Ship Lydia. Ship Harvey is sailing to the north at 32 miles per hour, and Ship Lydia is sailing to the east at 26 miles per hour. How fast is the distance between them changing at 6 a.m.? So in our problem, we have like our diagram. So Ship Harvey is this one and is sailing to north, and Ship Lydia is sailing to east, but Ship Lydia is 200 miles away from Ship Harvey, so that's why we have this one. And then to get our values, we have that the velocity is equal to distance over time. So we get our positions that are A, B, and H, and we get the derivative of position, that is velocity. So that's where we get dA over dt, dV over dt, and dH over dt. And in our problem, we have that is 32 with distance of A, distance of B is 26, and we have to get the velocity of dH, so that's why we have the question mark. And to get the distance, we have that the ship starts sailing like at 2 a.m. and they stop sailing at 6 a.m. So it's like 4 hours of difference. And we just multiply the 32 per 4 and we get the distance, and we did the same thing with the B. But here we did like 104 plus 200, so we get 304 miles, because it's from the ship, the difference of the ships, and then the distance that Ship Lydia does to the east. And we have to find H and the velocity of dH when the hour is 6 a.m.
First we have to find the distance between both ships. So we apply the Pythagorean theorem, and we find that the distance between both ships when have passed 4 hours is equal to 329.85 miles. Then we have to apply this formula with the formula of the Pythagorean theorem. So we have to derive this formula, and then it's equal to the derivative of h squared is equal to 2h multiplied by dh over dt, that instead of dx we are going to apply dh over dt, dA over dt, and dV over dt, and deriving this formula.
So on this step we are going to substitute h by these values, and we're going to do the same thing with a, dA divided by dt, b and dV divided by dt. Then we're going to solve this equation by multiplying, and we are going to get to this result, and then we have to isolate dH divided by dt, and this is going to give us this. Miles with miles are cancelled or simplified, and we are going to obtain this. This is going to be our result. This represents the rate of change when the ships are moving with respect to the distance. Finally, we know that rate of change is the change of a variable depending in the change of time.
Also, we can say that this project helps us to understand the topic and how it is applied to the real situations. As here we can see that in a real situation we have like two cars, each one moving to north and the other to the west, and how fast is going to change the distance with respect in time.